Okay, we're now going to come up with a simple set of equations that can be used anytime that we see a CMOS voltage amplifier. So the first thing that we need to do is recognize whether we're dealing with a common source, common gate, or common drain amplifier. A common source amplifier is an amplifier where we're going to find the output at the drain of the transistor due to an input at the gate of the transistor. A common gate amplifier is one where we're going to take the output off of the drain of the transistor and the input on the source of the transistor. And finally, a common drain, or sometimes called a source follower, we're going to take the output on the source and the input on the gate. Now, we know that the generalized gain formulas are always going to be something like GM times RT, regardless of the topology, so we just need to figure out what big GM and big RT are for each of these topologies. The first thing that we're going to do is figure out what the intrinsic resistance of the transistor is looking into any of the terminals. So for instance, R little g is the resistance looking into the gate. Now we know for a MOSFET, the gate should be a perfect insulator, so our gate resistance should be approximately infinite. When we look into the drain of the transistor, it's going to depend upon what's connected to the source. We're going to see the output resistance times 1 plus the transconductance of the transistor times the resistance connected to the source. And this is the external resistance connected to the source. When we look into the source of the transistor, we're normally going to see approximately 1 over GM. I say approximately because this one can also depend upon the size of the drain resistance. So our general formulas for big GM and RT then become, for the common source, big GM is equal to minus little gm divided by 1 plus little gm times R connected to the source. And RT is equal to the intrinsic resistance from the drain in parallel with the external resistance at the drain. When we look at the common gate amplifier, we'll find that big GM is simply equal to little gm, and R total is equal to the intrinsic resistance at the drain in parallel with the external resistance at the drain. Finally, when we look at our common drain amplifier, we would find that GM is equal to little gm divided by 1 plus little gm times R connected to the source, and R total is equal to any R connected to the source. What we find about all of these, the common source amplifier can be used to give us current gain and voltage gain. The common gate amplifier can be used to give us only voltage gain, it doesn't give current gain. And the common drain amplifier can be used to give current gain, it does not give voltage gain. The common drain amplifier or source follower is sometimes used as a voltage buffer. So in the next set of slides, we are going to look at inspection analysis equations for bipolar junction transistors.